Hello everyone, welcome back to Coding Trades. So in this session we are going to see about NumPy. So you will see what is NumPy and how to use this NumPy and how to install this NumPy module. All these things you will see now. So before that we will see that what is NumPy is. NumPy, we can say that it is a numerical Python which is of library. It is in Python library which will work with arrays. So we don't have any special things for the array, so we are using NumPy. We can also use lists, but it is far better than list. NumPy is far better than list because it is very faster, we can say. And in this NumPy, we can use like Fourier transform. We can use numerical things like Fourier transform, and also matrices, and also linear algebra. All these things, all these domains we can use. And actually this NumPy is created in 2005 by Travis Oliphant. He is the one who created this NumPy. And we can say that it is an open source project which can be available freely in the market. In the internet. And it is NumPy is a general purpose array processing package. General purpose array processing package, and it is having high performance which will support the multi-dimensional array. We can say that this NumPy is also ndarray because it can support multi-dimensional arrays. And it is a fundamental package for scientific computing, like if you are using the universal functions like sine, cos and all these things, this NumPy will support. So that's why it is called as it is a fundamental package for scientific computing. And why we use NumPy? We are already having this list which will support few of the arrays, right? So but why we are having why we are going for NumPys? Because lists are slow process when compared to the NumPy. So it is 50 times faster than this thing. List is 50% less than NumPy. So we can say that NumPy is very fast. And we can say that the array object in NumPy is called as ndarray, as it is supporting multi-dimensional arrays. So we can call it as ndarrays. And in arrays, the NumPy are stored in table of elements like rows and columns is stored. And the dimensions of the array is called as rank of the array. So what you call this dimensions is, if it is zero-dimensional array, the rank of the array is 0. If it is one-dimensional array, the rank of the array is 1. If it is two-dimensional array, the rank of the array is 2 in that way. So we can also call it as ndarray if it is having n-dimensional array. And these are the things you should remember, very important things. This is the rank of the array and the shape of the array. The rank of the array is dimensions of the array. The shape of the array is couple of integers giving the size of the array. So it will give the size of the array along each dimension. So it is called as shape of the array. These are the two things important in the NumPy. So we will see why is NumPy faster than list. Because NumPy will store in, first thing is it will store in table of elements. That means it will store in continuous places. So we can easily access them and we can use it perfectly. So it is having very efficient manner. If we are having in a table, then it is very efficient. Rather than storing in different locations, if it is storing in continuous places, then it is having efficiency more. So that this behavior is called as locality of reference. So this is the main reason why we are going for the NumPy, because it is faster than list. So which language is this NumPy written in? NumPy is written partially in Python, and for faster communications written in like C or C++. So next is how to install the NumPy. So it is very simple. You can go with this command because With the PIP, we can install all the libraries. Whatever the libraries you want, you will go with PIP space, install space, whatever the library you want, you will go with this. So let me install this PIP or in NumPy. Actually, I'm already installed with this. So let me show you PIP space install NumPy. So if it is not having in your system, then it will give you like downloading and collecting all the requirements and all these things. So I have already installed this, so it is giving me requirement already satisfied, and this is the location it is telling us. So I have already installed this NumPy. This is how you will get. So if you want to check the version, how you will check? Just pip underscore version you will check. And before that, you should check the NumPy, whether NumPy is installed or not. So let me check. So I will give the simple example like how to import or how to work with the NumPy. So here I am giving like import NumPy. So if it is not installed, then you will get a skewed and red underline here. So you will get like this. So you can see like if I am going to install, like if I am importing Kiwi module or if I am importing anything, so you will get this red underline. So this Kiwi is not installed in my system, so I am getting red line. So as I have installed NumPy, I will not get this red line. It will go. So this is what the confirmation you can see. And also you can check the version. I will show you how to check the version as well. So here I am importing the NumPy and I am using the variable ARR to store this array. ARR equal to numpy.array. This is a array, one-dimensional array. And I am printing the array. So let me see the output, what I will get. So on the output, what I will get is this array I will get. I got it 1, 2, 3, 4, 5. So this is how you will work with the single dimensional arrays. So next coming to the version or alias name. So as you are having different names in your mother will call you different name and your friends will call you different name, right? So we can also call this modules or this libraries as other name. So how can you call this as with the other name is import NumPy as NP. Whatever the new name you want, you will give with the help of as followed by the name you want. And see here, you are getting the red underline, skewed underline. So you can call this as, so we are calling with the other name, right? So you should call with the other name here as well, np.array. So now you can see, so I will first difference, I will give like 6, 7. So here already it is 1, 2, 3, 4, 5. So now you can see the difference. So you will get 1, 2, 3, 4, 5, 6, 7. So when you are giving the alias name of this NumPy, so you should access with that alias name itself, np.array. So this is how you will use it. And next, as I have told you, version, how to check the version. So np.__ version, you can get the version, what version I am using. This NumPy. When I am recording this video, it is 1.19.1. NumPy version is 1.19.1. So NumPy creating arrays. How to create a NumPy ndarray object? So we can create an object like import NPy as NPy. This now we have seen like this, right? But how to check the class, the type of this array? So we have already studied this type method, right? So if you are giving this type, what you will get is what type it is. The array is of what type, which data type or which type it is. So it is of type numpy.ndarray. So So this ARR is of type ndarray numpy dot ndarray. This is what it is given. So next thing is, so we know that what is the type will do, and we can see. So next thing is how to, so it will not only support the list, but it also support the tuples. So here we have given the list. Now I am going to give the tuple. So this is what tuple. So let me import the array numpy, as I have removed import numpy as np. So here I have given the tuple. So whether you will get the tuple or not, let us see. So you can get the tuple also in the format of array. This is how you will get it. So next thing is dimension. So what do we call this dimension? Just now we have studied, right? So just pause the video and recall it and post it in the comment box. So this dimensions of arrays we can call it as rank of the arrays, right? So this is a zero dimensional array. So I have given only one single element. So it is called a zero dimensional array. I am giving here one dimension as we have seen in the earlier examples. So this is what? One dimensional array. If you are giving the two-dimensional array, you can give here like two-dimensional array. And for the three-dimensional array, you can give like this. So this will be considered as one dimension, and this will be considered as a two dimension, and this will be considered as a third dimension. Like this, 1, 2, 3, 4, 5, 6 will be one array, and next is the other array. Next, so let us see this example. All the ranks you will display. How to display the ranks you can see here. So here I am going to display you the ranking of the array. So import numpy as np. So array equal to np dot array with rank 1. So you can see that this is the rank 1 and this is the rank 2, and here I have passed the rank with the tuple array created using passed tuple. So you can see what you will get. So array with rank 1, and this is with array with rank 2 as we have given here rank 2, and the next one is passing the tuple. So this is how you can do with this. So the next thing is accessing the array index. So we know that how to access the array index, like we have seen in the list as well. So you will start with a of 0 or a of 1 like that, right? So let us see here how to access the array. So this is what the simple example how to access the array. Let me copy this. Then I'm copying, pasting here. So you can see the output here. So how you will get this array. So array equal to, I have initialized this array here. And then I'm printing what is the initial array here. You can see here the initial array, whatever the array here we have given, it is stored in ARR. So you will get the initial array, and then here I am going to slice the array. So we have seen how to slice, right? In the list also we have seen. So colon 2, that means what we are accessing here, only the first two rows. We are accessing only the first two rows, and here I am giving stepwise 2. That means leave 2 and access the remaining. Leave 2 and access the remaining ones, like that. So you can see here -1 and then 0. So -1 then 0. Leaving 1 then accessing. So you will get 4 and then 6. Then, so since we have accessed only 2 rows, it is given only 2. So leave 1 and get 1. Leave 1 and get 1 and leave. Get 1 and leave. Here we can see like that. So this is what about the slicing, and then you can also specify the what elements you want. So here I have given the indices as 1, 3, 1, 2, 0, 1, 3, 0. So you can see here, the array will start with 0, 1, 2 and 3 here. So 0, 1, 2, 3 here. So this is the position, it is 0 and 0, right? So what we have access 1, 3, right? So this is the position of 1, 1, 0, 1, 1, 1, 2 and 1, 3. This is the position of 1, 3. So first one 1, 3 you got it as 0. Next one I am accessing 1, 2 which is this one 6. Next I am accessing 0, 1 this one. And next I am accessing 3, 0 and this is the one. It is starting with 0, 1, 2, 3. So we will get 3, 0 like this. So this is how you can access the array elements. Next thing is how to check the number of dimensions. So we are giving different number of dimensions. We don't know how many dimensions we have given. So in that situation, how can we check the number of dimensions? So we will give the array and I am printing here initial array and I am slicing the same example. Sorry, I have copied the same example because I want to give the same thing. Okay, let me paste this. So with the help of ndim is n dimension. With the help of ndim, you can check which dimension of array you are using. You are giving as 0 dimensional or 1 dimensional or 2 dimensional or 3 dimensional or n dimensional. You can check with ndim. You should remember this ndim. So I am importing numpy and I am saving this. I am using the variable and I am giving the array and I am calling a.ndim because a is the variable which I have stored the array. So a.ndim means ndim will give the which dimension of array it is. So it will give you 0 and as I have given here 1 dimensional array, b.ndim will give you 1 and I have given here 2 dimensional array, it will give you 2 and then 3 like this. This is how you can access the with how many types of how to check the dimensions of the array. Then if you are giving the if you want to give the high dimensional arrays, you have to create an array with 5 dimensions and verify that if it is 5 dimensions or not. So let us see this simple example. So creating like n dimensions. So here I am creating 1, 2, 3, 4 as a single dimensional array and I am creating n diamond is equal to 5 and I am printing the array. You can see what is the array here and I am accessing here arr.ndim. That means I am requesting that which dimension it is. Either it is 5 dimensional or 6 dimensional or 10 dimensional like that. So here we can see the number of dimensions is 5 dimensional array. So for this I am giving here 5 dimension. So here I am mentioning that it is 5 dimensions. So if you mention here it is 10 dimensions, if you give here 10 dimension and then if you run this, then you will get 10 dimensional arrays like this. So with the help of ndim, you can specify how many dimensions you want. And with the help of arr.ndim, you can get the number of dimensions you are giving. And then, so to create sequence of numbers, we can provide numpy. And also apart from this, we are having different things like arrange, linspace, and reshaping the array. Arrange, linspace, and reshaping the array. So what is arrange will do? So this arrange will returns the evenly specified values with a given interval. So just now we have seen the 2 when we are doing the slicing. So with a given interval it will return. And linspace returns evenly specified values within a given interval. So even specified values it will return. And reshaping the array. So reshaping array, with the help of this you can reshape the array. For example, you are having A1 to AN, and if you want to reshape, to convert it into another shape like B1 to BM, then this is the required, like what A1 into all these things, A1 into A2 into AN equal to B1 into B2 into BN, all these things. That means the original size of the array should be same. It should remain the same. Then only we can reshape the array. So this is how you can reshape. So we are also having the flatten array. So what is this flatten array will do is, it will we can use this flatten method to get a copy of array collapsed into one dimension. So if it is collapsing into one dimension, you can use this. So by default you are having row major order, that is C. If you are doing with the row major order, you will use C. But by default you will do with the row major order only. Then if you want the column major order, you can specify that it is F. So we will see with some examples what is C and what is F. We will see now. So I have given a simple example for this. So let me show you. So this is one of the example. So here I am creating the array and with the data type float, d type as float, and I am printing the array. So you can see whether we will get it in float or not. So you can get it in pass the array created using pass list. So 1, 2, 4, 5, 8, 7. So just you are getting this array, and so this array is of type, and then this is of creating tuple, creating array from the tuple. np.array 132, and array created using passed tuple. So you will get as passed tuple as 132. Whatever we are passing, you will get. See here, I am giving here just 3 by 4, 3 comma 4, np.0 3 comma 4 I am giving. That means you will create a matrix with 3 by 4 matrix, and then you will pass all the, you are giving all the values as 0. So you can see here, it is a 3 by 4 matrix and you are giving all the values as 0. And create a constant value. If you want to create a constant value array of the matrix, that means if you are using the complex functions, so you will add up these things like you will get the 6 plus 0j, 6 plus 0j with 3 by 3 matrix. With 3 by 3 matrix, you will get all these things. So here I have given 6 plus 0j, 6 plus 0j. Like this you will get. So the next thing is basic array operations like addition, subtraction. How we will do with this, you will see here. So we can do anything, addition, subtraction, multiplication, whatever you want you can do with the array. So here I have given the array 1, 2, 3, 4, and I'm giving the second array B array as 4, 3, 2, 1. I'm giving the two arrays here, and I'm adding 1 to each element. 1 to each element. You can see the output as well. So here this is adding 1 to each element. So 1 plus 1 is 2, and 1 plus 2 is 3. 3 plus 1 is 4, and 4 plus 1 is 5. So you will get the resultant matrix as 2, 3, 4, 5. So you can check here 2, 3, 4, 5. This is what adding 1. And I am subtracting 2 from the B array. So from here I am subtracting 2. So you can get 4 minus 2 is 2, 3 minus 2 is 1, and 0 and minus 1. So you can check here. This is what subtracting the elements. So after adding, you will get one array. After subtracting, you will get the other array. Then sum of all the array elements, A dot sum. So here I am summing up 1 plus 2, 3 plus 3 is 6 plus 4 is 10. So if you want to sum up of all the array, you will use a function called as A dot sum. So it will sum up all the elements of the array. And then I'm doing here is binary operation. So here I'm performing only unary operation with sum. Here I am performing binary operation. That means two operands are there here, A and B, with one operator. So I am doing binary operation here. What I am doing? A plus B. That means each and every individual element will be added. 1 plus 4 is 5 and 2 plus 3 is 5. 3 plus 2 is 5 and 4 plus 1 is 5. Each and every element will be added to the other array element. Then you will get the resultant array. So this is how you will do. Then next, unary operator. So just now we have seen a simple example with sum, right? So you will get also min, max, etc. all these. So you will call just array.max. Then you will get the maximum element of this array. So you will see now. So you will get maximum element, minimum element, all these things you will get. So I'm calling the maximum function here array.max. So among these the maximum is 9, right? So the largest element is 9. So here I'm calling array.max. So when I have called here axis equal to 1, it is row wise. When I have called here axis equal to 0, it is column wise. We should remember that. If it is 1, it is row wise. If it is 0, it is column wise. Largest element among rows is, they are asking. So row wise maximum element is 6, 7, 9. And column wise is 1, 1 and 2, like that. Then sum of all the elements is 38. And cumulative sum along each row is 1, 6, 12. 1 and 1 plus 5 is 6. And 6 plus 6 is 12. So like this. 4. Then 4 plus 7 is 11. And 11 plus 2 is 13. So we are doing the cumulative addition, cumulative of all this. So for that, what you are using? CUM. So this is about the cumulative sum. If you are using these methods like sum, max, min, cumulative sum, all these things you will get. So if you want to do the binary operations, you will give here as A plus B for the addition of the two arrays. You will give A cross B and A dot B. Sorry, A multiplication B, A dot B. This is the dot product and this is the multiplication. And coming to the universal functions. So universal functions like exponential, square root and sine, cos, all these comes under universal functions. So how can we do with the help of universal functions? So here I am giving here as pi. So we know that pi value 3.14, it is a universal value, right? So I am giving here pi by 2. np dot pi by 2 is here I am assigning 0, np dot pi by 2, np dot pi. And I am using that sign values of array elements, np dot sign of A. So you will get the sign value. You will get some like decimal value here, 3.14 by 2, like that. So you will get the sign value and you will get the exponent of this and you will get the square root of this. So you have a look at the output so you can understand. So it is 0.0.0.0 plus 1 raised to the power of 10 and then 1.000 like that, 1.224. So this is how you will get. The exponent values are like 1, 2.7 something and then 7 point something and 20 point something. Square root values are like 0, 1, 1.4, 1.7. So this is how you will get all these things. So you can use square root, exponential, sine, cosine, all these things you can use with the universal functions. Whatever the universal functions we have, we can use this. So this is about the introduction of the NumPy. For further, we will discuss some more things in the next videos. Thank you everyone. So I hope you enjoyed this video. Please like, share and subscribe. Thank you everyone.